Hello dear viewers, how are you? I hope you all will be fine and doing well. In this interesting video lecture, we are going to find the regular expression for a language and also the finite automata for that language. So dear friends, first of all, in exams you will have a descriptive definition of a language. Language, let me write over here. I hope you will be able to see it. A language of L having string ending with double letters, like here the L is equal to the set will be language set is A or A and B. We have to draw a regular expression for such strings having double A or double B in the end of that letters. Okay, so let me write a regular expression over here. First of all, we are going to find regular expression for this one, regular expression, right? So in start, let me write an example over here of A B B A B B B. So this is a language ending with double A, or A B B double A. This is a language ending with double A. So we have to draw such expression which obey these rules. So in start, as you can see, we have any type of value, any type of alphabet or letter. So we can say like this: if A and B both is possible, an unlimited occurrence of this is possible. This is the closure. You know, the closure means it is like a power. If we take it 4, so we can write A or B 4 times. Okay, so now this is an expression for all the values of for all the strings that can be possible from this, like ABB, any string, but we are interested in such string that is ending with double A or double B. So here we will use double A plus double B. This plus sign is used for OR operation. We can use this or this, right? So now I hope you let me zoom it for you little bit. You can see this clearly. This A plus B, closure A double B, double A plus double B. Now we will move to the finite automata of this. Let me zoom it a little bit. Yes, now I hope you will be able to see it clearly. Now we are moving toward its finite automata. Here is A plus B and A double A plus double B. Okay, so we have an initial state in each infinite automata. So this is the initial state. What is possible? A and B is possible. So let me move it toward this. So it will, another state is formed, and here another state is formed. From each state in finite automata, there will be that number of transaction which is given in the alphabet set, right? So we have the letter set is AB. So 2 transaction is possible from each state. So here A transaction will occur over here and B will occur over here. So the 2 transaction has been done from this state. Now we are moving toward these states, right? So if again A comes, so it will move toward its final position, final state. You must need to draw these arrows because it shows the direction that where the transaction is going. Okay, and the other transaction will also come over here, that is B. Okay, this is B. Now if here sorry, no, here it is not B, it is A. By mistaken I write A and B here. If B comes over here, it will come to this state, and if A occurs over here, it will goes to here. Now this transaction has been completed. This is B and this is A. Two transactions occur from here, two transactions occurring from here. Now this state is remaining. If A comes at the end, it is okay, and if B comes at the end, it is okay. But if B comes at this state, so then it will come here, and if A occurs at this state, then it will go over here. So let me write A over here, and this is B over here. So this is the finite automata. Let test it. So we have an example: A B A B B B A A. It is ending with double A, right? So now A transaction occurring from here, then we have B is coming over here, then again we have B is coming over here, then we have A is going toward this state, then we have B coming B again B, and it's going toward, when A occurs, it's come to this, and when again A occurs, it comes to the final state. It means the finite automata we draw is accurate for this. And if we pass such string ending with like this single A, so let's test this. As you can see from this three B's, B come over here again in the loop, and if a single A occurs, it goes to the non-final state, and whenever it goes to non-final state, the finite automata will be not good for that. So dear friends, I hope you like this video. If you like this video, please subscribe our channel, so in future you will never miss any notification about our new videos. Thank you so much for watching.